All right, so we're going to be carrying on with the last section for these notes for today. And hopefully we'll get through this not with much difficulty. So again, if you have any questions for Kim tomorrow, you can ask her. Obviously, I just see there's other questions that are popping up. But you will give another talk tomorrow and on Thursday, discussing various aspects. Yeah, so we can carry on. Where were we now? Get everything ready. So one of the things I actually wanted to highlight was just the one thing that I guess Kim mentioned was obviously best practices, because when you're trying to code or do research in any way or form, try to get things done, and that usually adds up to errors at the end of the day. So what you're trying to also focusing on this course, I guess for this week, is certain best practices when you're cleaning our data and using it so we can process it effectively, and also learning a little bit about GitHub and creating Git repositories. But yes, let us carry on. We are going to carry on with the next part of the section. We were working with this data set with patient data dates, and it seems that everybody was able to get to this point so far. If you haven't, I mean, again, the recordings will be made available, but you can always look at the notes to see what, how things can be done. All right, so let's see what the next part of it was. All right, so the next topic that was covered here was about dropping nans or dropping empty cells, because it might be times where you might given might affect your results in one way or the other, or try to bias it in some form. So if we look at the data frame we have at the moment, we can see there's actually only one nan or one somebody's drawing on Zoom. I don't know who is that's drawing on my screen. Not sure how to stop somebody from doing that. Let me see. I can't see a way to stop somebody from drawing on my screen. That's weird. Okay. But in any case, so we had this data frame, and there's actually only one nan or empty cell, which is row 22. Again, with the other examples we had row 18. We filled this value, we filled this nan in with the mean of this column. That's why we got these two values to replace it. So if you just want to get rid of the nans, what you can do, you can just use a pandas function called df.dropNA, and that'll drop or just remove all the nans that are available or that you can find. And then you would also need to add another line of code to kind of reset the index. But let's just see what this happens if this actually does anything to our code. Drop NA, and hopefully you'll see that most of the lines of code in Python are quite self-explanatory. They kind of what you're trying to do is how these functions are described, which is a nice thing about Python compared to other programming languages. So let's look at that. Okay, let's run the code. See what we get with our data frame. Okay, so can anybody see what happened when I did that? What happened when I did drop NA in place equals true? What did this line of code do to what it was before to what it is now? What happened? Sorry? Yeah, it removes a null value, right? So The index number 22 disappeared. But you'll notice that the entire row actually was removed. So all the data was actually removed. So if we go to the other observation we had above, let's just remove drop NA. The other observation we had where we used where we fill the value, or we just replace it with the average of the column. So this gives us more nans to work with. Open it again, and we should see, yeah. So we have NAT, and now we have more nans, right? So it's row 18, 22, and 28. Okay. So if we now run it, see what happens if we run it. It has now removed, there's no more row 18 anymore. Row 22 is gone, and I think it was row 26 most likely, because it's not there. So it completely removed those rows anytime it sees anytime it sees a NaN or NAT, it'll remove the complete observation from that row. So all the observations, all the data that's stored, it'll just completely remove it. So that is one way to process a NaN. It's really up to you. You know, how you want to process the data, and if it will affect your analysis afterwards or not. Right. So again, I'm showing you tools that you can use, you know, when you're processing your data. There isn't always a correct answer, but you have to figure out what will work best for you. All right. So there was one more situation where one more value we needed to fix, which was this 450, because this would bias our data. I mean, it's again, we can remove the line, or we can maybe fix it, right? A few people mentioned, and as is mentioned in the notes, this could just be a typo, right? They typed 450, but it should just be 45, and it kind of makes sense if you look at the other data points. That, I mean, it would be most likely in that range of 45. So can anybody give me code that I can maybe, okay, well, how would I resolve that? How would I maybe change that value to make more sense? Right, so can anybody give me a line of code in the chat? How do I fix this number over here, 450, because it doesn't fit with the rest of the data. It is an outlier. So what options can you give me in the chat, please? Code that works on your side, please. And don't guess, it needs to work on your side, and please send it to me. So give me a line of code that'll fix line 7. Thanks, Louise. That looks very familiar. Can anybody give me an alternative? Any other approach to fixing it? Okay, so there's a few options. So you can drop, locate. Okay, so prudent. So if you I can drop it, that would mean we're just completely removing it. And there's one more thing I wanted to comment about with drop NA, is that if you would have noticed that the indexes are not consistent anymore once we remove it, right? Because what pandas does is completely removes the index value as well. So it counts from 25 to 27 and from 17 to 19. Right, so that's something I just forgot to mention as well. Whenever using drop NA or any drop command in pandas, it'll remove the complete row as well as the index. So how do we fix that? Maybe before we get to changing this 450. I just forgot to mention that. How do we first fix the index in this column? What do we do to fix it? So please put in the chat. How do I fix the index so it's counts index is updated? So Isabelli, yeah. So we will look at a way to fix it as well. So I just asked for a few options. So it's just a few options. So yeah, so we can reset the index. Yeah, so that's better way to do it. So we'll just reset the index. So that should give us the correct numbers again. So it counts everything correctly. Yes, everything is sequential, which is what we want. Cool. Okay, so back to number 7. So let's see what everybody said with that. So obviously the comment, obviously the one option was you can replace it as is using this command over here. So with df.lock, this allows you to change the value based on this index for this column. So let's see what happens if we run it. So this is to change a specific value in a cell. See what you get. There we go. So 450 became 47, right? Which is a reasonable way to work with that. Another option was to drop it completely. So Prudence says, let's just drop the complete row. So we just don't have it anymore, which is plausible. You can do that. That's not a problem. Again, you're just losing the rest of the data that you're working with, or you can make it a NaN as well. So maybe it doesn't skew your data. So it's really up to you. So again, you can drop it, you can remove it. And yeah, so I'm seeing all the same kind of comments for that. There's another example you can use replace. So that's another way to do it. So instead of using .lock, .loc, you can do this too. Let's see. Okay, well, you changed it to 50. Okay, that's fine. I mean, we'll give you the same thing. Maybe we change the average. Yeah, Sophia, yeah, you can also change to the average, just like we did with calories. It's not a problem. Again, we going through, showcasing a few examples of what you can do in this situation, because you might have like hundreds of these cases, and that's our point of automation. You can do this with multiple rows and multiple columns. We're only doing one at a time, but obviously the power behind Python is you can automate things. So yeah, so that's I think everybody seems to be on board with that. Yeah, so the full example code I did actually give in Canvas. One thing that I didn't show you is just say print df. If I want to just print the data frame completely, what does it give you the complete data frame? That was one of the features of there is this line of code that says display max rows. So this is used if you have a lot of rows, like more than like probably I have here. So I think it's I think more than 50 as far as I can remember. If you have more than 50 rows, pandas will automatically truncate it. Will show you the first 5 and last 5. If you just put this line of code here, set option display max rows, it'll show you all the data. But obviously there's a caveat to that. There's an exception. If you have a million rows, don't do that. It'll crash Spider, and you have to restart it. So there's obviously a reason why they have, that there. So that's just something you can find in the notes as well. It's not really useful here because, I mean, we only have about 27 rows. So, but it's something useful to know for your own data. All right, the next section is looking at data transformations. And this is moving on to more of a section where we want to do maybe calculations on groups of data, aggregate data using something called group by. So pandas can group by categorical data. We can also do things like merge data sets and join them, and also filter and manipulate data to create new variables, right? So again, we're just showcasing a few features that you can use in pandas. And again, the whole idea is to start you thinking about how can you use this with your own data, with your own research. Whole idea is to give you ideas at the end of the day. So at the end of each of these lessons, I always ask, okay, now think, how can you use this for your own situation, right? I'm giving you these options. So like later on, you can ask in the chat, like, I have this data, how can I do that with it? How do I clean it up? How do I do this and whatnot? Tomorrow, we're going to be focusing more on EDA, or exploratory data analysis, where we'll do more plotting and visualization, and other aspects as well. So, we won't be covering too much about ETL anymore, or transforming data too much, but more on the visual side tomorrow, and communicating your data effectively. So again, if you have questions or comments, your own data, I have this data, how do I clean it up? I have a problem with this, how do I transform it? This is where you ask questions. We need feedback from you, because again, these are generic examples, but I need your feedback, so we can kind of assist you and hopefully everyone else. All right, so the next section we're going to do here is applying data transformations. So this is the section we're on at the moment. So we're going to focus on aggregation, append and merge. So if you have multiple files, for example, if you have, I'm only using 2 files here, but you can have 100 files, for example. How do you append them if they have the same column names? And then how do you merge, right? So merge data. So for example, if you're familiar with SQL databases where you have files that have different column names, but they are related, usually by like maybe the ID column or index column. If they are related, how do you merge them to extract information or filter? So if you are familiar with SQL databases, I mean, this should be quite familiar to you, and a very powerful tool in pandas as well. And I think there is something that is actually missing before we even get to that. And this was done beforehand. Give me a moment. Yeah, that's the one. There's actually a piece of code missing. Well, a line of code at least. Okay, but we can do that together. That's not a problem. All right, so let's go back to iris data. All right, so iris data, where is it? Can somebody give me the code again? Where's Iris? Don't really want to read from the URL, prefer to just read it. Where's Iris? Okay, there it is. Did it have headers or not? I can't remember. Let's call it DF rather. It's better to call it data frame. Okay, let's comment it out. We don't need it for now. Okay, so this is quite clean data, sorted correctly. We're going to be working with this. All right, so I want to add a new column. All right, so this is a sepal length. Can somebody tell me how do you extract all the column names? Instead of looking at the data frame itself, how do I extract all the column names, so the headers from a data frame? Please give me the code to do that in the chat. How do you extract all the column names? Complete code, please. That works. Okay, that took about 2 minutes. Okay, so print df.columns. See what happens. Patient treated columns. I'm not sure that'll work. But yes, there we go. So these are the column names. Now for those that want to be fancy, that are experts in Python, I don't really like how this looks. Okay, let's say it's column names. It's very messy. Let's see what column names looks like. Okay, that actually looks better. So these are the column names, right? So what I want to do is now add another column. This might be, there's actually another example, to list. Then print out. No. Well, it's better than having the index thing there. It's okay. Anyway, we get the idea. So I want to add another column. And for whatever reason, I don't know if this makes sense or not. I want to do a calculation on the sepal length, for example. I want to create another column that will square that number, right? So ultimately, I want another column called sepal length squared. Okay, and it needs to be the squared value of the current sepal values, right? So can somebody give me a line of code, single line of code that can do that? For those that are new to programming, I don't expect you to answer. These are people that are familiar with pandas already. The answer isn't in the notes, so you can't copy and paste. So how am I going to the square of the sepal length in this new column? So I'll create the column already. So I can say df, this is what the column is going to look like. But I want the square of the values in sepal length. So how do I get that? So for example, some of the values would be 5.1, So that'll up like first row would be like 5.1 times 5.1, for example. So that'll be the first element, for example. So, but I want to do that for the complete row. Sorry, for the complete column. I want to do that in a single line. So how will I do that? How will I do that? Okay, so we have a few examples popping up. Stuff, thanks as well. So let's see what we get. Columns. Any other takers? Okay, I see Hadrian uses apply, which is quite nice example. The one was I was actually going to use it as well. But if you see they actually all work. I mean, we can use apply as well. See if we get the same one. What I'll do is I'll just create a another column right next to it. Let's call it 2. Yep, everything. All the same. So because this is quite a simple calculation, I mean, this can work on this column. However, if you have more, complex function or complex calculation, using the dot apply method would be more appropriate in this case. I won't go too much depth about dot apply. I'm just showing you an example of how we can apply like a custom function to each single value in a column. Right. So I will put this in the notes later today. But this is how you can apply certain, maybe you want to do square root of each value or multiply it or add, something else to it. This is how you can do that by creating a new column and then applying some numerical calculation to it. So thank you for that. So what is the next part of the notes? We discuss grouping by different categories, right? So let's see what we have here. So we have, let's create a variable called grouped. And what we do is we call our data frame and we initialize group by method. And we're going to group by class. What does it actually do? Well, let's run it and see. Grouped. Well, it's a whole bunch of stuff. Can't really make sense of it. This means that we have to use it, we'd have to start using it some way or form. Okay, so let's say, for example, we want to, for example, find the calculate like the mean, sum, and count for the squared values based on the different groups, right? So we look at the example that I have here, like mean squared values equals grouped, and then based on the sepal length squared, the one we just worked out. Right, so you can choose if I want to work out the mean. I can also work out the sum, or if an account of them as well. I mean, there's various different options you can choose. All the documentation has it there. And if we print it out, let's see what it says here. Mean squared values. Let's see what it's printed out. So what does it do? For the various categories, Iris, Setosa, versicolor, virginica, it works out the mean. It works out the mean of what? It works out the mean based on the sepal length squared column. So this is the average for that category only. We grouped it based on that, and we got able to work out the mean, right? So within a line of code, we can filter and extract information quite easily with pandas in that way. So you can again work out the sum or the count or anything like that. So it's a very powerful way of filtering and sorting in Python, and falls under various domains that you can use it. Okay. So I don't see any questions about that, so we can carry on. The next section is, again, focusing more on working with multiple files. For example, if you have two different files, right? So in this folder, I have two files called person split one, which has some information of random people. And you might have like 100 files that you maybe want to combine into one, and maybe filter it and sort it, maybe extract certain columns and certain rows only. So this is one way to do it using pandas. So what we can do is let's first this will be a way to do it. Obviously, there's various ways to combine multiple files, but the simplest way is just to read in each one as a data frame. So we say df1 equals pd.read CSV. And let's get the relative path for the first one. And then df2, let me just copy this, because it's very similar. It's going to be 2, and it's going to be df2. Right, so I can read in these two variables, these two data frames. And then if I go to my variable explorer, I should see them. df1 is there, and df2 is there. So all I really want to do is append them, right? To have and add them together, so I have a one file. So how do I do that? I have I can use the concatenation method function. Say df equals pd.concat, and create a list of them, df1 and df2, and let's not do ignore index just yet. Let's first try that and see what you get. So what I'm doing is I'm trying to add two data frames together. So let's see what df is. There we go. So we had a split. So the first one was 0 to 10. The other one was 10 to 20. And I was able to add the two files together. So I have one, so I can filter it and sort it and analyze it afterwards, right? So very, very useful. Again, you can do that in Excel if you have multiple sheets, for example. You can extract each of them individually and add them together. I can filter and sort however you want, right? You really, it's really up to your imagination what you can do in Python, and specifically in pandas. Okay, so we saw what that looks like. So let's see what ignore index equals true, what that does. Why did I put that there in the notes? So that will that just updates the index as far as I can tell. When you use the concatenation method. So Chepo, what if the two files are not similar, different columns and rows? So can you give me an example to work with? And I'm assuming, do you mean the files are they related somehow? So if you can give me an example, then I can see how we can present it. But there's always usually, as I've mentioned before, Python is it's a very versatile programming language, and you can pretty much do anything with it, that if you put your mind to it. So yeah, so we've done that. And then something I guess that most people might be more interested in is working with files that have different column names, probably what Chepo is referring to is more related to SQL databases where they have relationships between the tables themselves. So let's have a look at the files we have here, which is, I think it's this person, yeah, education. So here's a data file that has the education details of a person, and then the details of the person in terms of the work information, everything else. All right, so these have different columns and obviously a different number of rows. A number of rows don't really make a difference at all when you want to append or merge. So, but obviously these have different columns, so you can't just read them in kind of together. You would have to find a way to merge them. And Python obviously, or Pandas, has a merge method that you can use to be able to combine these two based on a common relation, right? And that is the same ID, right? So assume these are people at a company, and they all have the same, person ID. Like some of you have student numbers. You all have a student number, but on your student database, you might not be all located in one table. You have different tables that you are, associated with. That is all kind of linked with your student ID, for example. So, okay, let's join these two, for example. So let's get them. I can just copy and get them. I can just copy from the notes here. So we have person education and person work. So let's read these two in, make sure that's all working fine. DF1, yeah, there's university information, and here's your work info. And again, these two data frames, they are related based on the ID. So it could be like a work ID, a person ID, whatnot. This is how they are related, right? So let's try and merge them together, and we can do an inner join. So can anybody tell me what an inner join is? What is an inner join? What is an inner join? So what's the outer join? And therefore, what is a left join and what is a right join? You could. Yeah, so we're getting the right answers there. So joining only by values appearing in both datasets, only keeping the rows if they're same IDs in the two files. Okay, so let's see what happens when we run that. Oh, wait, we're done with that one. We want merge inner. So in this case, we get the university column as well as the work information as well. So we can get all the information that we need together, and we can obviously filter it now. Once we've gathered all the spreadsheets together or tables together, we can filter it and sort it. So again, if you're familiar with SQL, this must be quite familiar to you and useful again if you want to try pandas. So if you look at the you can look at the notes again. You'll see the different parameters you can choose when you are trying to merge data. So by default, it is an inner join. So it will only match based on if there's a match between both tables. And what we're doing here is we're telling pandas function the relationship between these two data frames must be the ID. Okay. So again, if you're familiar with SQL, this is quite standard, approach. And then can anybody tell me what an outer join is? I know Jan did give a very brief summary, but maybe a bit of an explanation as well. What is an outer join? Well, what will be the result of an outer join? What is an outer join? All rows are kept from both tables, even if there's no shared ID. Yeah, and the important thing is if there's no match, then there'll be nans everywhere else. So if you have SQL data you want to share, I can try and upload it. But again, it's just to really show you the what you can do with pandas and the various functions of it. Yeah, so that's all I want to discuss for this section. We have another one. We'll be looking at filtering after the break, and then a summary of cleaning and pre-processing, and then just loading data. How to now, we've read in all our CSV data and Excel files and text files. How do we actually create them, right? How do we create our own CSV file and Excel file, right? So we'll just discussing that after the break. And any questions or comments, please put in the chat. Any data you want me to, showcase your own data, you can also upload that to the chat channel. All right, we'll take a short break now. Thank you. Okay, so hopefully everybody is ready for the last part of today. The question is, how do I merge two different data files using the date as the identifier? Oh, that's interesting. In this case, I want to select and merge date and data, and only the dates that has data on both parameters. It sounds like a tongue twister there. Why don't you give me an example of your code? And we can look at it. I think you repeated it in the next line. Yeah. So why didn't you give me your example of the code, upload something of what you're thinking about, or even just a snapshot of what you're thinking about, because it seems a bit confusing what you're trying to say. Okay, so I think we are still recording. So the last section for today. Let's see. Done merging, that's all done. Okay, filtering. So let us go back to let's go back to the Iris data set. Actually, there's one more thing I want to go back to the Iris data set. There's something that is not very that is not too useful. It's not a problem, but sum this all out. Yeah, I think I should have this people one back there. Okay, let me print it out so everybody can see, maybe, because that isn't too clear. So printf. X rows. So based on this data frame, can anybody recommend maybe something that is or one of the columns, put it this way, can be maybe represented in a better way. Put it this way, it's the class column. I'll give it you that. The data in some way or form is something is redundant, or it's just extra information that isn't really necessary in the class column. Can anybody see what it is or what I'm thinking? Yeah, which is not necessary. It's extra information that just clutters up the class column. So can anybody recommend how to get rid of it? Right. Again, if you want clean data, that's understandable to everyone. So can somebody give me a line of code that works, that can get rid of it? Rahul, I'm not sure why I want to drop anything. Sophia, can we take Iris and leave the second part only? Yes, you can. That's what I'm asking. I want all the Python buffs to give me a line of code that can do that for me. We kind of did do that already before. Yeah, Chepo, so removing Iris in the class column and leaving the rest, because it's just redundant data. It just takes up space, really. So kind of a line of code that can just remove it. Okay, so Grant is using string replace, um, which looks like a good option. It's one option you can do. See how it works. So for this column, using the string accessor, then this method, look for iris and dash and just replace it with nothing. Looks like that should work. There we go. Something that the column looks a lot better. Thank you. All right, so in terms of filtering data, I think we did look at one example in yesterday's lesson where we were able to filter the age, for example, or certain value. So how can we do that with iris data? So for example, let's look at data frame again. So how can I filter this data based on the sepal length that is, or only give me the rows where the sepal length is bigger than 5, for example. So for the rows bigger than 5. So that the condition is this column needs to be bigger than 5. How would I do that? Can you give me a piece of code for that? One line of code. Filter the data based on the sepal length bigger than 5. We did something similar yesterday. Anybody give me code for that column? You're filtering data based on that column, so sepal length bigger than a 5. I only see one person typing. Hopefully they have the answer. Okay, let's have a look. Oh, that seems to have worked. The data has been filtered based on this column sepal length only, and none of the values in the sepal length column is less than 5. So that seems to work. Okay, and how do I, for example, only see data for the category of Virginica, right? In the same way, I only want to see Virginica rows or the data for Virginica. How would I do that in a similar way? Can you give me a line of code that can do that for me? So filter the data frame, so I only see Virginica data in this data frame. Okay, let's have a look what Cheslin wrote here. I can't see much there, so maybe let's store it as a data frame. or kind of right over our current data frame. Or something's not happy there. Probably that is a problem. There we go. Yeah, that seems to work as well. So now our data frame is again filtered based on these two criteria, based on certain value and a certain category. Okay, so we've covered quite a bit on just extracting and transforming data to clean it up, because these are the most common problems you might see or might have when you're working with data. And in the notes, I give just some things to look out for when you are processing your data and you're trying to filter it. So the first one is if you have the difference between a zero and a nan, right? So a zero is we didn't actually have examples of that, but just make sure that you differentiate between a zero, which is the actual value, and a blank cell, because they can mean two different things and will skew your data if you don't have it. So just put the notes here so we can kind of focus on it. So there's a filling in zeros. It's different to blank because the zero is actual data that was measured. And then null values. Again, it's different to zero. This is a null. This is something that wasn't measured, right? And should be ignored. So sometimes we had an example yesterday of somebody that input or gave an Excel spreadsheet that had a lot of highlights on their cells, and they were trying to make the data sheet pretty, which, you know, if you're using it as a notebook to kind of explain things, which is fine. But again, you can't extract that information. You can't, you know, highlighted columns or things like that isn't something that pandas or any software program can, you know, correctly interpret, right? So if you want to highlight certain values or something is unique, you can just create another column and assign that, you know, a certain true or false value or 1 or 0 compared to the other ones, right? So making things pretty or nice on your Excel spreadsheet might be useful for, you know, highlighting things, but in terms of pandas, rather add columns instead with info that highlights those things. You know, sometimes you also see comments in cells. So this also leads on to the previous example we had, where we had words, where we had that text with numbers in the column. So again, try to split that up and make a distinction between you know, numbers and words. If you have categorical data, that's fine. But usually, you know, if you have numbers in it, you kind of want to do numerical analysis with those values. Yeah, so comments and cells, try to avoid that, just add it in a separate column. So you're not mixing data types. Very important. You're entering more than one piece of information in a cell. So again, similar to that year, that adding numbers to years. So we had an example with that category of 30 to 34 years. So you don't need to add years to that. You can just add it to the column name if you want, or create another document like a spreadsheet or anything like that, or README file that has that meta information or information about the file itself and the variables and what they mean. Again, using problematic field names, so avoid spaces. I think we've mentioned that many times. Avoid spaces, numbers, and special characters. I think I've given you enough examples of how to, you know, create variable names, as well as file names as well. And obviously using special characters in data. You know, just try and, you know, you have to always avoid that because you will have issues nevertheless. Okay, so the last section, hopefully won't take too long. Is this really the last part of ETL, again, which is a subset of what software engineers do, which is extract, transform, and load. And typically it's something we do more second nature in what we do, but it's useful just to define these terms. So all this while we have been reading in data, or we have another pipeline. We want to send the data to a compute cloud, which we can process the data somehow. So our data is ready. Now we can, start processing it in another pipeline, for example. So how do we do that? So again, pandas makes our life quite easy. So for example, let's say this is our final CSV or final data set we want to export to our pipeline where we can start analyzing and processing it. So all we have to do is say df dot to CSV. So if we do this, it should pop up with different types of options. Don't know why it's up. Excuse me. Sometimes it appears, sometimes it doesn't. So to CSV. So can somebody give me a name of filtered data for the Irish data set? Give me a useful name that we can work with. What we're going to call our CSV file. What are we going to call our CSV file? Jason is typing something, Chanel's typing something, several people are typing. We're very keen to see what they're going to say. Pulsar. Okay, I don't know what that has anything to do with the Irish dataset, but maybe it does. I don't know. Pulsar. Okay, pulsar.csv. But it's also a good convention because as Dr. Kim Martin was speaking about, to kind of follow good, follow certain practices to output our data into a separate folder. Okay. I do see better names there. Clean Iris and Iris Clean, Iris 2024. But we'll, Pulsar is interesting, so I'll stick with that. If any astronomy students want to give me the data to work with, you can. It just must be in a decent format. I have been quite biased to biology and bioinformatics students. It's just Iris is one of the most famous data sets specifically for machine learning. So give me a data so we can work with it. I don't mind. So we can create a file here saying df.tocsv. You run it and we should see our file being created. Let's have a look. Let's actually go to the folder itself and let's have a look at it. I don't see it anyway. Where is it? Oh, what happened? Also.csv. Why did it give me a problem? Why did it give me a problem? It shouldn't give me a problem. Why did it give me a problem? Let's first get rid of that and see if anything changes. Maybe it doesn't like the word pulsar. Pulsar.csv. Try it again. Huh. Interesting. In any case, there we go. There's our file. So our file has been created, and there it is. All right. So the pandas we created, we've cleaned the data, and if we open it up, open up, and there's our kind of filtered data or cleaned up data, and our data sorted here. So it's interesting why. Oh, forgot to convert it. I think there was option 2 to convert it in Excel, which I ignored, which is fine. But in any case, I mean, the file was created and it is saved. Can open up with maybe Notepad if you want to see it in its flat format, and you should see data as is. There's probably a rounding error over here, which you can probably fix. Which you kind of should fix. I wonder if you see that same issue in pandas if you look at the variable explorer. No, it probably rounds it for you. So I can probably round it beforehand and then save it again to your CSV file. Yeah, so that is saving to a CSV file. You can also save it to, yeah, so I see a few questions about no path. Well, Janus, can you tell me, is this a path? Where is this going to be saved? We say it's no path, or where should this go, or where will it go, or where did it go? Okay, thank you, Tanya. Yeah, it'll go in the working directory. So there is a path. It'll just go to the same location where this file is, which is ultimately over here. So it was created in the same directory as my Python file. Okay, but again, with usually following a convention to put our output files in a separate folder, let's maybe create another folder, right? We can call it output. Output also. So we can save all our files separately. So we have input files and output files, and it can be quite clear how we got to that. So output, and then what happens? What does it say? Cannot save file into non-existent directory. That is because Pandas doesn't create a directory for you. You have to first create it yourself. In Python, you can create a directory if you want to. But it's not too necessary to show you how to do that, but it is possible. Okay, you can do that. So let's just create a new folder called output. Let's run it again, save and run it. It should be happy. Didn't complain. And you see under the output folder now that we have our pulsar data. And let's see, I have somebody sent actual pulsar data. Let's see. Doesn't look like too much data, so just for fun, we can read it in. URL equals PDF equals pandas CSV. So hopefully tomorrow we're gonna. This has been quite dry in terms of. This is not very visually appealing, right? Seeing this text all the time. So ultimately, we like to see plots and figures and graphs and things, and that's what we're going to see tomorrow, right? Because I'm sure everyone's tired of just seeing text. We want to see something that's visual. So if you run this, let's see what happens. We go to a variable explorer, df, and see the data. Okay, everything looks decent. We have a column names, no nans, everything seems quite consistent. So probably a good data set to use. So thank you for that. What other examples do we have here? So that was reading in the data. So it's filtering. So we loaded, so now we're able to create a file, create a CSV file, and then we were also able to export that to a different folder. So again, is this one I created here, is this a relative path or is this an absolute path? Is it a relative path or absolute path? This output / pulsar.csv. It's relative, right? It's relative to the current working directory that I'm in. So if I wanted to put that somewhere else on my machine, or even on a maybe on a cloud as well, I'm sure that's possible too. So it's relative, right? If you wanted to give maybe on a different drive, we can give the absolute path of some other folder to put it. We can do that too, right? So I mean, it's the same, works the same way as worked with when we read in data as well, or we're reading files. Yeah, the other examples again are quite self-explanatory. Creating an Excel file as well. I think you really just go through the notes to that, and then exporting to a JSON file. Yeah, so I'm actually not really going to go through the rest. I think you can really go through it on your own. Hopefully you got the idea, obviously, of how to do ETL in terms of extracting data, transforming it, and now loading it. So again, you can start thinking of your own cases, your own use cases. How can you do that in Python? And thinking about that. So again, feel free to upload your data on the chat, and we can look at different examples we can play around with. So again, tomorrow we're going to be doing EDA and specifically exploratory data analysis. The visual aspects, like visualizing data now in graphs and plots. That'll be in the morning, and then in the afternoon, we're actually going to change our schedule a little and give you an introduction to NumPy. It's also a very important library to know how to use. It's an afternoon talk, and that'll be done by Dr. Andrew Gill from Stellenbosch University. So he'll be doing that tomorrow afternoon. So that'll be on NumPy. But otherwise, the rest of the schedule will stay the same. We'll finish early today, so you can start working on your projects. And yes, you have your project to do, and anything else, and you can go over the content. We'll try to upload the Zoom recordings as soon as we can. But yeah, thank you, everyone. That's all for today. You can paste any questions in the chat, and we'll look at it. But thank you very much. That's we're done for today. Thank you.